Alright, now we got a pentagonal prism because we got the two pentagons on the top and bottom, so that's considered the base. And then we see all of the lateral faces are rectangles right there, which we would expect out of a prism. Now we do have the net on this one, and you can use the net if you'd like, but I'm actually going to proceed without the net because I believe on several of the assignment problems that there is no net as well. Okay? So without a net, what do? Well, essentially we're going to make a net, and we just kind of make it non-formally, right? Just informally. So for example, I'd say, hey, look, we got the top there. It's a pentagon, which is good. And what do we know about that pentagon? Well, it shows this length from the middle of it to the edge. That's a 90-degree angle, and that's a 8.9. I guess it doesn't give the units on that. That's fine. But what do we do with that 8.9? Well, and we've seen that word. We'll see that word in not only today's classwork, but also in the assignment. That's called an apothem. An apothem goes from the center of a polygon to the outside at a 90-degree angle. And you could think, well, could it go right here? And then the answer is no, because then it wouldn't be at a 90-degree angle. So this is nice because then it allows us to solve this because we have one part of the triangle that we need, particularly in this case the height. And so the last thing we would need on this is the base value right here, which, since this is, it didn't say that this is a regular pentagon, but that's this length right here, which is 13. So all of these lengths around the pentagon are also 13, okay? 13 units, whatever that is. So if I wanted the area of just that one triangle right there, I'd have to take 13, multiply it by 8.9, and then divide that by 2. So let's go ahead and figure out what the area of one of those triangles is. And yeah, some of you know the shortcut at this point, what you would do to solve for the rest of that pentagon. Now when I put this in the calculator, it tells me the area of the triangle is at 57.85. That'd be square units, right? But we see that that's only one triangle out of 1, 2, 3, 4, 5 triangles. So I'm going to multiply this by 5, which will give me the area, the full area of one of these pentagons. So 57.85 times 5, and that's the area of one of the pentagons, 289.25. Now we acknowledge that there is a second pentagon on the bottom and the top, right? So we can multiply this by 2, and that will then give us the area of both pentagons. So multiplying by 2 then gives me 578.5. And this is the area of the pentagons, both pentagons together. Okay, so that's an important value. But now what I need is the area of each of the rectangles. So I would say, look, we got a rectangle right here. And in fact, since that's a 13 by, it looks like a 5 rectangle, they're all 13 by 5 rectangles. This rectangle right here is 13 by 5. Same with this one on the edge right there, 13 by 5. So we're looking at this rectangle over here. I took this one and then we moved it over here. It's a 13 by 5 rectangle. So I want the area of that one rectangle first, 13 times 5, which is 65 units. And how many of those do we got? Well, that's 1. Then we have this one on this side. That's 2, 3 here, 4, and then this fifth one, right? Which we would expect 5 rectangles because this is a pentagon. So I'm going to multiply that 65 by 5, put it in my calculator, and that tells me the area of all of the rectangles is 325. I'm going to label this one because it is one of the answers. That's the lateral area, 325 square units. But if I want the total surface area, I still need that 325 from the lateral surface area, but I also need the 578.5 square units from the two pentagons. So let's go ahead and add these together. So there's a 5 and 13, carry the 1, 903.5 square units. This was the total surface area. Okay. So, I mean, is it possible you could have drawn all 5 rectangles? You could have, but hopefully we understand that once you get one of those rectangles off the lateral faces, there's 5 of them, so you can just multiply by 5 as well.